I'm Alex from eBay Research, and this work was presented in Wisdom 2018. It was done during my period in Yahoo Research, and it was done together with Ido Guy from eBay Research, Idan Spector from Google Research, and Dan Perek from Yahoo Research. The goal in this paper is to build a recommendation system which will simplify the photo sharing process for the users. So, the data that we have built our research on is taken from Flickr. Flickr is one of the largest platforms for photo sharing and storage on the web. It has more than 90 million monthly users in more than 63 countries. More than 1 million photos uploaded daily, and more than 10 billion photos are already on site. Another feature that we should be aware of in eBay is that in Flickr is that you can share your photo publicly, meaning you can say that everyone can see it and it can be searchable. So, the motivation for our paper. With mobile devices, we take a larger number of photos, ever-growing number of photos. We can see here the lack of y-axis is intended because it was confidential. But we can see that the number of taken photos, or the number of photos uploaded to Flickr, is going exponentially. And you can see that from 2008 to 2012, it grew 6 times and 16 times until 2015. And I guess it stays the same in these years as well. And on the other hand, we have a decreasing number of shared photos, or the portion of the photos that is shared is decreasing. You can see that from as high as more than 40% in 2008, now it is as low as less than 5% in 2015 for mobile devices. So let's summarize the motivation. We have growing number of photos, but we have decreasing number of shared photos. We speculate that the reason for the decreasing sharing portion is that people don't have the time or the state of mind to sift through all the taken photos. So in this work, we're presenting a recommendation algorithm which will help the users rank the photos and avoid the tiresome task. So let's define the research task, and I'll quote. Given a set of photos taken by a given user in a certain time frame, rank them by their likelihood to be publicly shared by the user. For the task, we used a unique dataset that we had internally in Yahoo, where we took user days. I will use the term user days. User days are basically all the photos of a single user in a single day. So we used user days which have more than one public photo, at least one public photo, but less than 15% public photos. We took those public photos as a conscious decision of publicly shared photos because we wanted to avoid people who have a default of public or private. So we took only the days where someone chooses to share part of his photos publicly. So let's look at a photo stream. Basically, it's a sample of a photo stream. And the first thing that we've noticed is that there's a lot of almost identical photos in a photo stream. I'm sure that everyone knows that if you have a mobile phone, you just you can click as much as you want, right? It has enough memory, and then you upload everything to the site, and then you get something like this, and then that is due to lack of space because I took the middle picture like 20 times. So the first thing that we did was to group the photos to near duplicates. You can see here the groups, and we'll elaborate how we did that. The second part in our algorithm was to rank inside each group which is the photo which is most likely to be shared. And the last part was basically to rank the scenes. We ranked the groups by the likelihood to contain a publicly shared photo. So let's start with the dataset for the grouping phase. We had 70 user days with 1,500 photos, and we put a 15 seconds threshold between the photos, meaning that if more than 15 seconds passed, it's a new group, and it doesn't matter what appears in the photo. We had two of the authors, and one of them was me actually, labeled the set. We had a kappa agreement of 0.77, and we labeled 70% of the photos were near duplicates. The decision was a binary one. We decided on every photo whether it's a new duplicate of the previous one. The guidelines appear here in the box. It's standard guidelines. So what we got? We got that 45% or over 55% of the photos are new duplicates of another one. And a very important thing, and I think it was a great motivation for our paper, we've noticed that only 1% of the groups have more than one shared photo. Meaning that people, if they share photos, they will not share more than one photo from a group. There is no point in sharing duplicates. Okay, so this phase was very simple, and we used only 3 features for that. We used the time proximity, the time delta between 2 photos, the color histogram, the color similarity. The difference between, basically the color similarity is the difference between color histograms of 2 photos. We computed the overall histogram difference by averaging the histogram difference for each RGB color, calculated using a Hellinger distance. And we used embedding similarity. Embedding similarity is basically cosine between 2 embeddings. The embeddings that we've taken were from, basically it was the last layer of Flickr phototextual auto tagger. In Flickr, they have an option of basically telling you which object they located in your photo. So they have textual tags. So we took this network, we took its last layer, and we used it as an embedding for the entire paper. We'll see we used it in future steps as well. So we can see that the embedding actually gives us most of the gain, but all of them together, where is the guy that fixes it? That's fine. So, but all of them together, they have additional gain. Now we'll go to ranking photos inside a group. Here we needed to choose those groups that have at least one public and at least one private photo. Otherwise, we cannot rank them. We wanted the public ones to be higher than the private ones. And we used, in this phase, we used each dimension of the embedding as a separate feature instead of cosine similarity. We just had 4K features. Plus, we added other features as well as NSFW score, static score, time delta, positional statistics, like which of the, where are you located in the group. So if you're the last one, it's a very good signal for you to be a good one. And we can see that one of the better baselines were a chronological one, meaning that we've noticed that a lot of times the last photo in a group is the one that is being shared. I speculate, I guess, is that people do the decision of sharing the same as I do. I just keep clicking on their phone until I'm satisfied with the result, and then I stop. So the last image in the group is the best one. And the final phase was basically to rank the groups, or rank the scenes. We wanted to guess which of the scenes is the most probable to contain the photo that you would like to share. Here we used the entire dataset of user days with more than 0 but less than 15% of the photos which are public. Here we can see that, or we can't see, but if you would look at the presentation, you would see that the best baseline is a group size. Basically, the group which has the most photos is the most likely to contain a photo that you want to share. Probably because you care about the scene and you just took a lot of photos of it. But we can see that here the algorithm is really taking effect. We outperform by far every other classifier or every other baseline that we found. We added to this phase, we added the features like group size and all kinds of group statistics. We can look at each group of photos and say which is what is the average aesthetic score, what is the time that passed from the first to the last photo, and so on. And finally, we actually compared two scenarios. One scenario is when you do allow duplicates in the recommendation that you show to the user. If a user don't mind seeing two photos which are near duplicates, we can get to really good results, and I will explain the table. The bottom part is no deduplication at all, meaning that we do not show dedupes at all, meaning only one photo can appear. There is no dedupe, meaning that all the photos can appear. So we just rank the groups, and we show for each group we show everyone. That is not the best option. We also tried several Ks. K is how many photos will we choose from each of the groups. And we tried to choose only the best one from each group, maybe two of each group, and so on. And we tried to predict which will be really shared. And we tried with several Ks, and the best one was 2, meaning that the final algorithm, if we are tolerant to duplicate photos, is choosing 2 best photos from each of the groups and recommending them using the algorithm. That's it.